Okay, dokie. Let's move on with early warnings for all in the Asia Pacific region, and let's look at the next thing from this report on hotspots of existing, intensifying, and emerging drought risks under the baseline and climate change scenarios, keeping again in mind that 1.5 degrees C, 2 degrees C warming. The temperature projections will be quite reliable at regional scale, not at local scale. Rainfall will not be good even at regional scale, but we have to deal with these things. Okay, so Southwest Asia, Southeast Asia, Pacific, North Central, and Northeast Asia. So northern. Northeast Asia, so medium to very high risk, northern China. So these are existing hotspots with high risks, medium risks, very high risks, and Aral Sea region of Turkmenistan, Uzbekistan, and southern parts of Kazakhstan being very high risk, in Mongolia, and so on. I won't read the details because these are available, and even in the IPCC reports they are discussed. If you look at what is projected for 1.5 and 2 degree risks in terms of hotspots of intensifying drought risks at 1.52 and hotspots of emerging risks, so new risks, and those at 1.5 and 2, you see that they have been estimated for various regions in each part of Asia Pacific. So is Southeast Asia really not going to have intensifying drought risk under 1.5? Unfortunately, you cannot say with great confidence because the monsoons are not represented so well, especially in terms of their changes over time. The way you would do it is you look at the historic trend of, let's say, the monsoon over South Asia, like India, Indian subcontinent, and Southeast Asia. They are not done very well by the models. You are using the same models and going into the future under several scenarios with to warming of 1.5 and 2 degrees centigrade. So you have to be very careful what the models are saying about droughts and rainfall over these regions because the baseline is not done so well. Keep that in mind. That's why I wanted to show these tables. So reading them in detail doesn't make that much difference in this context because I'm just trying to give you a sense that these reports exist and you can go and read them. So we are looking at existing hotspots in terms of drought risks, hotspots intensifying under 1.5 and 2 degrees centigrade warming scenarios, and emerging hotspots for 1.5 and 2 degrees C warming as far as drought risks are concerned. If you look at flood risks again with respect to baseline, looking at 1.5 degrees C and 2 degrees C warming, again the scales are very large, so taking action on these, for example, if there is in fact increasing, so this is in the baseline annual maximum 5-day precipitation in millimeters, so you get certain regions, let's say in South Asia and Southeast Asia and ENA, all these terminologies you know, and then you look at 1.5 degrees C warming under SSP3 that we discussed before, and you see there are some changes here. So if you want to address this risk projection of 1.5 degrees C, what can you do at such a large scale? Can you do something at this whole, for the whole region, let's say just of India going from mainland into northeast, versus there are also islands which are not shown here but shown separately. So you understand that taking decisions against floods, for mitigating them and preparing for them, adapting to them, will require very, very local information. These models are not capable of giving you that, but elevated risks and intensifying and emerging risks will give you some general idea of what you may have to deal with. Okay, and this is really important for small island states, because if you say your risk of heavy rain, annual maximum 5-day precipitation is going to increase, then how reliable is it? Because they have limited resources and they have to allocate them to various things dealing with sea level rise, fisheries, let's say salinization of groundwater versus heavy rain or drought. What can you do? So, you have droughts shown here. Oops, I cut it out, but nonetheless, this flood risk. Okay, you get the idea. So hotspots of existing, intensifying and emerging flood risks under baseline and climate change scenarios. Similarly, you have existing hotspots of flood risks and intensifying flood risks for 1.5 and 2 degrees C for the different regions of Asia Pacific, and hotspots of emerging flood risks for 1.5 and 2 degrees C. So if you say parts of China, then you're giving large swaths of land. You're saying southern Australia, which is pretty big, and they are having emerging hotspots as well as intensifying hotspots in all these scenarios. So how do they prepare? Okay, Pakistan, which is a very vulnerable but yet a developing country, and it's facing a flood every year since 2010. So what can it do to prepare? They have to do something because they know that the risk is already here and it may only get worse. But if you invest a lot and flood risks disappear, and then Pakistan is a semi-arid region, if they get into drought, then what happens if you make heavy investments in flood risks based on such projections? Okay, so this is what you are dealing with. Here is hotspots of existing, intensifying and emerging heat wave risks. Similar story. Heat wave should be more reliably be done because the scale of temperatures is larger. Rainfall is very local. Temperatures can be uniform over a larger region. You can think through it. If you're living in a place when you are hot, large region around you will be hot, but it can be raining here and not in the next neighborhood. So rain is very different than heat, but still the information is not very local, as you can see here. Heat wave risk baseline, so 1.5 degrees C. So this is the baseline in terms of annual days with maximum temperature above 35 degrees, and you see the hotspots there. And under 1.5 there are small changes, and then 2 degrees C with SSP3 scenario, again there are more changes. Again, preparing means shelters, hydration centers, warnings, early warnings, and so on. And early warnings also have to be very, very specific, local, because if you move all the old people into a shelter and tell them not to go out and nothing happens, they are going to be very unhappy, right? So these are tricky situations that you have to deal with. Similarly, there is surface wind risk. I won't go into it, but we'll come back and look at the next topic of the economic impacts of the heat wave. Every time you say climate risk and early warnings, everybody is interested in understanding how economies are being affected at local scale, regional scale and national scale, and also across nations, because you may be trading with a country that is dealing with heat waves and so on, and your trade with them will depend on how vulnerable they are to climate change impacts. And this works in many ways. For example, 2023 was a very warm year. 2024 continued to be warm. Now La Nina is coming, so you have to see whether warmth will continue or not. But when El Nino came and forecasts were made early in the year, India decided to clamp down on exporting rice and wheat. Indonesia, which buys from India, had price increases because they couldn't import rice and wheat from India. Okay, so it's before El Nino even happened, forecasts triggered some action on the part of India to protect its own food security, which affected the prices and food availability in Indonesia. Similarly, connected global economies means if you get hit by heat wave, crop damage or labor and productivity losses, let's say India is making iPhones and a heat wave puts half their workforce in a hospital, then the production line slows down, and then Apple is waiting in the markets to say, where are the iPhones? So you can see how globally connected economies are making things very hard. So you always look for local economic impacts, which includes productivity loss, production loss, and of course consumer confidence, food prices, inflation, and all those other good things. So we'll come back and discuss a bit more, but early warnings are meant to mitigate all these things: impact on people, impact on food and agriculture, impact on water resources, impact on economies, and so on. So we'll come back and continue the discussion. Okay.